Okay, this video is about why air movement is so important in the atmosphere, and by the end of the lesson we're going to learn how air moves and its impact. So hopefully by the end of the lesson you can explain how air moves and the impact it has on the environment and humans. So what I want us to firstly do is to look at these quick revision questions and write down a quick answer. So I want you to just pause the video and write some of those questions, write those answers to those questions. So what causes air to move? Well, the air within the troposphere is never at rest. It always is constantly moving. Around the equator there is bands of winds that have similar wind patterns. These are Hadley cells. Hadley cells form because the hot air condenses very quickly, which then rises. That movement then goes to the poles, but some of that hot air that warms that equator falls down and creates a cell. That's why it's called a Hadley cell. As you can see in the diagram, you can see the movement of air. So around the equator, that's what we see. The remaining air then moves on towards the poles, and as a result we have ferrule cells and polar cells. So basically our movement of air goes from the equator to the poles and vice versa. Some of it circulates into cells while the other moves into another cell. The warm air will then meet colder air, which is moving away from the poles. The warm air hits the cold air and then forms a low pressure system. The type of air pressure system that we get is very, very unsettled, cloudy weather, lots of wind. That wind is high pressure going to low pressure. That's always the movement of air, high to low. So yeah, that's how air is forced to move. In the higher sections of the troposphere, winds are extremely high, around 200 kilometers per hour. Commercial military aircraft use these winds, which are called jet streams. They use these because it helps the plane move quicker. At the surface, basically, as I've said before, we've got this high to low pressure. These are the variables that lead to constant changing wind patterns that we see in weather charts or synoptic charts. As mentioned before, Hadley cells produce low pressure systems. That hot air then moves on to another cell. In the southern hemisphere, they're deflected to the left. In the northern hemisphere, they're deflected to the right. The reason why they're deflected is because of the Coriolis effect. That's where the Earth's moving. It actually moves the air as well. In between those cells, we have what's called trade winds. In the southern hemisphere, they produce winds from the southeast to the northeast. In the northern hemisphere, they produce winds from the northeast to the southwest. Why are they called trade winds? Well, they were discovered by sailors, and it helped navigate early sailors around the world. That's why it took, a good 400 years before people started going from Europe to Asia, and then obviously later on to Australia. There are also winds around 40 degrees north and 40 degrees south, and they are very quick, and they're called the roaring Forties. Incredibly strong winds, and you'll see when they do the round the world boat race, they try and get there as quickly as they can, because that's where they get the quickest speeds. Around the equator, there is a band of no winds, and they are called doldrums, where there's no wind whatsoever, and people would get stuck, and unfortunately ships got lost. So that's how air is moved. It's all to do with the moving of the Earth. It's the different warming of the Earth from the sun, and then the sun heating the Earth, which then heats the air, and then they move in different directions. So generally the movement is the equator to the poles and vice versa, poles to the equator. We have sails, so hot air moves and then it cools. Some of that hot air then goes on to its next cell until it gets to the pole, where it cools again and moves back down towards the equator. So that is how air moves around the world.